Okay, so Guy, you've been on a Midwest tour and started when, on the 13th, I think?
Well, I have that written on a piece of paper.
Okay.
Fortunately, because I wouldn't know otherwise. I think I landed on the 12th.
Landed on the
in
12th?
Chicago O'Hare.
Okay.
And stayed overnight at a generous person's house. And then I was taken to Milwaukee the next day.
On the 13th.
On the 13th.
Okay, so today's the 25th, and you've completed...
That's right.
Okay.
I've completed the Midwest tour, which began with the first presentation on the 13th, I believe, and finished with the final presentation yesterday.
24th.
The 24th. So basically a 12-day tour with 8 or 9 venues in there. And we covered a lot of ground, thousands of miles. And it took a long time to create this Midwest tour because people who are willing and able to host me to talk about the unmentionable are few and far between.
The unmentionable. We'll get to that in a minute. Now, let's just talk a little bit about the different places you went to. Now, you started in Milwaukee.
First I was in Milwaukee, then I was in Chicago.
At the Unitarian Church, right?
Yes. More than 150 people there for that first presentation.
And then the second was...
And then it was another Unitarian church.
Those Unitarians.
We're seeing a trend here, aren't we?
Yes.
And that was in Chicago. And then Madison, Cedar Rapids, Ames, Iowa. That's Cedar Rapids, Iowa. Kansas City, Missouri, St. Louis.
Oh boy, that's a long way.
Indianapolis, Indiana. And wrapping up in Lansing, Michigan yesterday. And a couple of events in Indianapolis, if I'm not mistaken. So a lot of miles, a lot of wonderful hosts who volunteered their space and their house and their time and their food to feed me. And most especially, I was impressed with the variety and quantity of ice cream on the tour.
Don't worry, there's ice cream around here somewhere, too. I've even got a nectarine tree over there. They're not ripe yet, but
well,
just imagine.
As long as you have the ice cream.
The ice cream, I believe, is here. Now, what were some of the highlights that you could say on this, this foray, this 11, 12-day tour? What were some of the highlights?
The big highlight for me was meeting people I'd only met electronically. Only online.
Debbie?
Right. No, actually, I met Debbie. She came to the Mud Hut on her way to get dental work done.
That's right. I was so jealous.
A couple of years ago.
I was jealous when she told me that. I thought, darn it, I wanted to go up there.
So I met her, but folks like Linda, folks like the woman and her husband who hosted me yesterday, Lisa, and the person who hosted me for 4 days in her house in Kansas City? I think that's right. Kansas City, Missouri, that's right. And I met the guy who hosted me in Ames. I stayed in his house. He was an amazing 30-something individual. And apparently I'd met him twice in California. He'd heard me speak twice on tour there. And it motivated him to move back to Ames, where he was from, where his family was from, because of my message, because time is short and he wanted to be with the people he loved when the ship sinks. So that was inspiring, actually.
So tell me about Ames. Is that a large urban center, or what is it?
It's a college town.
A college town?
Yeah. It's so there's relatively knowledgeable people there. Reasonably sophisticated, who are willing to talk about a wide array of topics. And
so is it like 30,000, 40,000 people?
I don't remember.
Okay. We'll look it up.
I mean, at some level,
Ames.
It's just all a blur here.
Yeah.
Because even before I started this tour and up through the first several days on tour, I spent 13 nights in a row in 13 different beds. And one of those beds was an airplane seat. Because I took the red eye into Chicago and got in at about 5 o'clock in the morning.
From Belize?
From Spokane, Washington.
Spokane. All right, you were up in Spokane.
So I flew into Spokane, spent a few days up there, started the tour after I'd been in country for about a week, and started the tour by landing in Chicago and then driving the next day or the day after, to Madison.
So do you feel like it was a successful tour, or what would make it a successful tour? Maybe is a better question.
But for me, a successful tour, for me, a successful life as a teacher is to have one person change their perspective, change the way they live as a result of something they learned from me. So, for example, I present a couple of paradoxes now. That's the introductory science part of my presentation. One, civilization is a heat engine. So if we keep this set of living arrangements going, no matter how we power it, with solar panels or wind turbines or whatever, civilization itself is a heat engine. And turning off the heat engine warms the planet even faster because of these particulates in the atmosphere that are acting as an umbrella. So
sulfates?
Yeah, primarily sulfates, associated with burning low quality coals. Coal that is high in sulfur produces sulfates in the atmosphere. And they act as an umbrella. At the same time, burning that same lump of coal puts carbon dioxide into the atmosphere that serves as something of a blanket to hold the heat down. So we're really doing two things at once with industrial civilization. We're heating the planet by having this blanket and protecting the planet by having this umbrella. And most people are unaware of that, of the umbrella, because almost nobody ever talks about it. You don't hear 350.org telling us that if we switch the day after tomorrow to solar panels and wind turbines, that the temperature is going to accelerate very rapidly beyond the point of human habitation.
Because of the sulfates dropping out of the atmosphere.
Exactly. We're constantly putting them up there and they're constantly falling out of the atmosphere. We're just putting them up there a little faster than they're falling out. So we're always one step ahead. But if we stop putting them up there, it doesn't take very long before they all fall out. And then we experience the lack of global dimming or the absence of the aerosol effect.
And in your talk, you do mention this in the United States, 9/11, they stopped all the planes flying, and there was a marked heating.
Right. There was a significant change in the thermal signature of the Earth, of the whole planet, within a few days. So it's very, very rapid. So that's the first paradox that I would start with. Civilization based on the laws of thermodynamics and primarily based on Tim Garrett's work. He's an atmospheric scientist at the University of Utah. Civilization itself is a heat engine. So we keep it going, we turn up the heat. But if we turn it off, based on what we now know from studies of global dimming or the aerosol masking effect, it heats up even faster. So it's a damned if you do, damned if you don't sort of situation.
You mean darned if you do and
right.
darned if you
That's what I said.
Come on, there's kids
I have an
there.
accent. It doesn't come across sometimes.
Now, I'm going to play the old devil's advocate here and say, well, it's just a very minute, small piece of the atmosphere that we're talking about. That what are you talking about? Parts per million or parts per billion?
Parts per million.
Per million.
Yeah.
And so how could that have some kind of effect on our weather? I mean, humans, as I said, I'll play the devil's advocate and ask that question that most people ask and say, well, that's ridiculous. It's parts per million. That shouldn't make any difference.
Right. And that's something interesting because I didn't come across that on this tour. I didn't come across any skeptics, we'll say to be kind, about anthropogenic climate change, about human-caused climate change. Most people have heard it for so long and the evidence is so compelling that they admit, agree, accept that making even relatively minor changes in atmospheric chemistry will have an impact. And you see that when you get in your car. You get in your car on a sunny day and the windows have been rolled up. Well, that's basically a greenhouse on wheels. So all the sunlight goes in there, but some of the energy can't escape. The long-wave radiation is trapped by the windows, and what we're doing with greenhouse gases is putting a bunch of windows into the atmosphere. And yeah, it's not very much, but on the other hand, get into your car when it's 75 degrees outside and it's baking inside. you're rolling down the windows and turning on the air conditioner before you get very far down the road, because it might be 30, 40 degrees warmer inside than it is outside, Fahrenheit. So it really doesn't take much, and we've known about anthropogenic climate change, about the impact of carbon dioxide in the atmosphere in terms of its warming potential for a very long time. And people have done experiments in the laboratory where they increase really, really tiny amounts of carbon dioxide in an aquarium that's closed up, that contains air, not water. And you increase the parts per million of carbon dioxide in there, and it warms up. So, there's experimental evidence, there's the explanation, the hypothesis about how it works. All of this fits together. It was James Hansen who appeared before the United States Congress in 1988 and warned us about crossing the 350 parts per million threshold with respect to carbon dioxide. And really, he said that was the absolute upper limit. The Industrial Revolution began, we typically pin that at 1750 arbitrarily. And then there was 280 parts per million carbon dioxide in the atmosphere. Now there's more than 400. And if 350 was the upper limit, I don't think that was very safe. And in fact,
now
yes, it's about 410 parts per million carbon dioxide in the atmosphere. And Hansen never said 350 was safe, by the way. He said 300 might be safe, and 350 is really pushing it, and here we are at 410.
And so what is his message now? What is Hansen's message today?
His latest paper just came out a few days ago, and I can't remember the exact title, but it's something like The Young People's Burden. And I think this is tragic. This was a guy who was really pushing hard and pointing out the dangers of near-term rapid rises in temperature not that long ago, late 1980s, early 1990s, 20 plus years ago. And now he's saying that his generation, meaning basically our generation, if we're at the tail end of that baby boom and he's at the beginning end, our generation screwed it up, and the young people are going to have to fix it. with things like carbon taxes and nuclear power plants. And I think
carbon
that's
capture of some
right.
sort.
Fantasy technology. Exactly. And I think that's tragic, because what that's doing is what is going on college campuses and has been for a long time. Baby boomers standing up there at the front of the room telling the collected millennial generation that we really made mistakes, we really screwed it up, and you're going to have to fix it. Pushing the responsibility onto the future generations. It's like if James Hansen is driving a car, and he's sort of looking around and thump, oh, what was that? And there's a dog in the rearview mirror and he killed it. He doesn't then get out and tell the police officer that his grandson was driving and ran over it. But that's what he's doing with that latest paper. He's pushing it onto the future generations to solve the problem, not taking responsibility.
This was just in the past couple
within the last, yes, very recently.
July 25th, 2017, and so this is a recent paper within the past couple days or weeks or whatever.
Yeah, it was in July. So it's his paper that came out in July of 2017. And I think it was, I first saw it 3 or 4 days ago. It's such a blur on tour that's sort of hard for me to keep track, but it's quite recent. I would say within the last week, it might be 2 weeks.
Well, right, and it's also like, what was it, on the 12th or something, that big chunk of ice fell off the Antarctic shelf.
Right, the Larsen C.
Yeah.
After A and B went earlier. Yeah. This is the kind of thing that climate scientists said wouldn't happen for hundreds or thousands of years. And
10 years ago or something.
Right, exactly. They were saying
2100.
Bingo. And then 2 weeks ago, bam, it's in the ocean. And it served as a dam. It's not that it's going to cause sea level rise, just to be clear here, because it was floating ice already.
It's like in a drink, if you have a couple pieces of ice, it doesn't...
When the ice melts, it doesn't raise the level of the liquid in the glass. That's right. The issue here, the big issue...
Eureka! Wasn't there some guy that said Eureka in the bathtub?
Yes.
Who was that guy?
Eureka. I think it was Humboldt.
Yeah, I don't know.
I'm not sure.
Well, you know what I'm saying, though, that he said that, that there's some sort of law of physics that says...
Right. that the melting ice won't cause the...
won't raise it up.
Yes.
It'll just stay at the same
right.
level.
So anyway, Larsen C broke off, and it acted as a dam. So there's a bunch of ice, land-based ice or terrestrial ice, behind Larsen C. Larsen C is out of the way. The dam has broken. So now that terrestrial ice...
Right? Yeah. I mean, it's a glacier.
The size of Delaware. It's the size of Delaware.
The thing that broke off.
Yes. And it's floating now.
But what's behind it? How big is that?
That's terrestrial ice. That's way bigger than Delaware.
Yeah.
That's, this huge piece of terrestrial ice on Antarctica that now has a pathway to the ocean. And that could have really significant impacts in the near term.
Well, and the interesting thing about these glaciers is that, the people that observe them and, sit there with their cameras and stuff, you can see them move. This ice is in constant motion.
Right.
And I think that's the part that people forget. I mean, when you look at it, you go, it's just a chunk of ice. It just sits there.
Right.
But they do move. And this Larsen C falls off, and then what's behind it then is that much quicker falling into the ocean.
And it's not even that's the big deal. The big deal is that this is a harbinger. This is an event that was, quote, not supposed to happen for hundreds of thousands of years.
2100.
As of 10 years ago, this was a non-issue.
2100.
Well, it just happened.
Yeah.
So like so many other things, it happened faster than expected.
Well, now, who was the fellow that was, I think it was in the 1870s, that he was a scientist and some kind of a statesman, and he figured out this carbon thing.
George Perkins Marsh, you're thinking of him.
That's the guy.
In 1847.
Yes. And
he warned us about burning fossil fuels.
Right. And what did he say exactly? He said that, we're putting these substances into the atmosphere that will then warm up the entire planet.
Yes. And he said two things. He warned us about anthropogenic global warming as a result of putting greenhouse gases into the atmosphere. And he also warned us about the urban heat island effect. So if you put a bunch of buildings together, they absorb heat during the day, and then they re-release it at night. So it's going to stay warmer at night. Asphalt and concrete being the most telling examples. Right. Anything that acts as a heat sink, which is most notably bricks and mortar of some kind or other, concrete, whatever. So those heavy buildings, rooftops. Yes, absolutely, and solid objects more than less solid. So wood, for example, is not as big a sink as bricks or concrete or pavement, asphalt.
Or so he warned us. Or something.
So he warned us about this stuff 160 plus years ago.
And from his warning, though, I mean, did people pay attention? Did people say, whatever, or I mean, what was the response from in 1840? People just didn't care.
I don't know if there was any. I don't know of any information in the wake of that warning. And then in 1896, we had the first refereed journal article by Svante Arrhenius, who went on to win the Nobel Prize in Chemistry, warning about the carbonic atmosphere that we're creating. Carbonic acid, this is how he referred to the atmosphere, meaning putting carbon dioxide into the atmosphere as a result of burning fossil fuels. That was 1896. He actually indicated that the global average temperature would increase by 1 degree Celsius in 104 years.
And this is in the 1890s?
This is 1896. April of 1896. He said, in 2100, the temperature of the globe will warm up 1 degree C above what it's at now. And he missed it by about a quarter of a degree, which isn't bad 104 years in advance, and it's the first refereed journal article on the topic of anthropogenic climate change.
Okay, well, for our listeners, let's explain the referee journal articles and information. Where do these come from?
Yeah, this is what scientists do pretty much their entire careers. This is what I did for a very long time. They either collect field data.
Emeritus?
either collect field data, and that was my forte. I would have graduate students, and we would go out and collect data in the field on which species are responding various ways to different experimental treatments we would apply, we would assign. And other people are just monitoring. Other people are taking secondary data. Like, there's all this amazing data in the United States based on weather records. So hundreds, probably thousands of places in the United States, there's a rain gauge. And somebody has been measuring the amount of rain in that thing at 8 a.m. every day for the last 100 years or 200 years. So we have all this rich data, and same thing with maximum and minimum temperature for the data. And so people can put together these huge data sets and look at trends over time. Henry David Thoreau was walking around Walden Pond, and he recorded for a few years the first flowering date of every species of flowering plant. And then somebody comes along more than 100 years later and repeats the exercise. They get their graduate students out there. Let's look at the same plants, because they're pretty much all still there, and see what date they're flowering. And it was pushed ahead for a wide variety of plants. So whereas, say, the average flowering date for Achillea milliefolium was May 10th when Thoreau was at Walden Pond.
In the
1840s, I think it's 1840s, something like that, 1840s.
He only lived there for a couple of years.
Middle of the 19th century, that's right, but he lived in the area for a while. And then somebody comes back in the early 2000s, so roughly 150 years later, and finds that Achillea milliefolium, and I'm just making up this as an example, but say a species, Achillea milliefolium, whereas 150 years ago, its average first flowering date over a course of a few years was May 10th. Now it's April 15th or something like that. So it was pushed way forward because it's getting warmer earlier.
On average?
On average.
Across.
And he did that for a whole bunch of different plants, for a wide variety of them, and they all showed this profound pattern. And so that's just one example, but now we have data from so many sources, including how ecosystems respond and the physical environment and how it's changing, and Svante Arrhenius's indication the temperature should rise about a degree, and it actually increased 3/4 of a degree, so a little more than 3/4 of a degree. So really not a bad prediction, considering what he had to work with 104 years in advance. And so we have all of this stuff going on. There's plenty of evidence now that anthropogenic climate change is going on.
It's upon us.
It is upon us. And not only that, it's
upon us in the sense, I mean, it's happening, put it that
yes.
way.
Not only that, it's apparent by now that we're in the midst of an event called abrupt climate change, which is a whole different animal
than anthropogenic.
Absolutely. So
Well, okay, go back to anthropogenic. What does that signify?
Human caused.
Human caused.
Anthropogenic just means we did it.
Okay.
Humans are responsible for it as a result of burning fossil fuels. And now...
Agriculture too, perhaps?
Oh, yeah.
And
well,
animals.
And that's another way to get greenhouse gases into the atmosphere, is to turn the soil over. Take a shovel, turn the soil over, you just release methane and carbon dioxide. So anthropogenic climate change has been going on for as long as civilizations, a few thousand years.
7 to 10,000
yeah,
in that range.
Yeah. So the Industrial Revolution really ratcheted it up with the burning of fossil fuels.
About
but we
1700.
About 1750.
1750, okay.
But that's just an arbitrary date that was selected.
Well,
because
we started burning coal.
Exactly. We started burning coal at scale.
Yeah,
in about 1750.
I mean, before that, people were making iron and bronze and stuff by burning trees or something, charcoal and things. It wasn't the use of coal or
right. And there might have been 4 guys in the village who were burning lumps of coal in their stove to stay warm, but it wasn't industrial scale. It wasn't the whole town having a central power plant. So that whole thing, right?
Right.